Okay, so here's another homework example that I've been getting a lot of questions about. And to be honest, a lot of us really have a good understanding of what the domain or how to find a domain, the technique behind that. However, we're forgetting about what does it mean to be a compositional function. So here I'm just going to do two small examples, and this is similar to the homework. So we're going to let f of x equal x plus 1 over x, and then g of x equal x plus 1 over x plus 2. And what we want to do is find f composite g, and then we're going to find g composite g, and we're going to state their domains respectively. So the first thing, let's just find f composite g. Now, sometimes the easiest way to visualize what a compositional function is to think about it in terms of like a machine almost. So basically, you have two functions, f and g. Now, the compositional function means f of g of x, which means we have to evaluate g of x first. Okay? So in this first, rectangle, I'm going to label it g of x, and all I'm going to do is just write what g of x actually is. So it's going to be x plus 1 over x plus 2. Now, in order for me to use this machine, I can only use values of x that will not break the machine. Think about it, I guess, if you want to, as like a calculator. Like this calculator is a very special calculator. The only thing it knows how to do is x plus 1 over x plus 2. So no matter what button you hit or what number you hit on the calculator, it's always going to just do x plus 1 over x plus 2. All right? So what we need to do is we need to say, okay, well, we don't want our calculator to break. So we're going to set the denominator not equal to 0 because we do not want the denominator to be 0. So we got to find what value of x will make that 0. So if I just do x plus 2 does not equal 0, and I solve this as if it was just a regular equation, so I would just subtract 2 from both sides. All right, I find that the first value that I cannot use is x cannot equal negative 2, and I'm going to put like a little square around that. Okay, now the second machine, all right, is going to be the composition of the two functions. So in this case, all right, it's going to be, and I'm going to be very particular on how I write this, so I hope you're paying attention. In fact, maybe this would be a good time just to drop the pencil and just watch, all right? So we know f of x looks like this, okay? And I'm going to zoom out here just a little bit so you can see. In other words, f of x, if you look in the top left-hand corner of your screen, is x plus 1 over x. So what I did is I put parentheses wherever the x variable was first. Now, I'm going to substitute in g of x. So wherever I see the parentheses, I'm just going to write g of x. So give me a second. Let me zoom in so I can write a little neater. X plus 1 over x plus 2. And then x plus 1 over x plus 2 again. Okay? So the composition of these two functions will end up being, after you do all your algebra and everything, it's going to end up being 2x to the second plus 6x plus 5 all over the quantity x plus 2 times x plus 1. In other words, you're going to have to simplify the fractions, you're going to have to find a common denominator, you're going to have to combine them, and this is what you end up getting. Okay? And now what we need to do here, and I'm going to use my highlighter, is we need to look at the compositional function, take its denominator, and set that not equal to 0, because we also need to find what are the other values that will break this calculator. What are the other values that will give me something that's undefined? So as long as I set each one of these factors that contains a variable equal to 0, using my zero product property. In fact, you can set them not equal to 0 if you want. That way it's already set up for you. And then you would just subtract 2 from both sides, and then you subtract 1 from both sides. Here you can see that x cannot equal negative 2 and x cannot equal negative 1. Now you already got the negative 2, which is right here. So to find the final domain, or to find what the interval notation for this domain is. All right, I like to just go ahead and create a little number line, and this just keeps things organized for me. I'm going to write -2, I'm going to write -1, and I know when x is -2, it's undefined. When x is -1, it's undefined again. So what are those intervals where all the valid or all the good x values are? Well, that's going to be from -infinity all the way up to -2, not including -2. And then in between -2 and -1. And finally, -1 to infinity. So, in interval notation, our domain for f composite g is -infinity to -2, or -2 to -1, or -1 to infinity. So the mistake that I've been noticing is that we are going all the way to the very end of the problem. We're going all the way to the compositional part, and then we're just finding these two values right here. All right? Where you can't do it that way. You got to remember, with a compositional function, you evaluate the inner function first, and you use that output for the input of the second function. In fact, your textbook has like a really good picture showing this. So let me find it real fast. So here's our class, here's our textbook. Sorry, I should have had this up, but this is a quick video. Functions, derivatives, or I'm sorry, functions and limits. 1.3. No, it's not in 1.3. At least I don't think so. Let me scroll down. Here it is. Combinations of functions. All right, so we're going to let this load real quick. And where is that picture? Here it is right here. So as you can see here, if we look at this from top to bottom, okay, you have your x, which is your first input, and that's going to go into g of x. That little blue looking, I don't even know what you would call that shape, is like, it's like the function machine. It's like a calculator. So x goes into g, and then it's going to output g of x. Then g of x is going to go into f, and it's going to output the compositional function f of g of x. Okay? So that's the way we need to interpret this. All right? Now, I'll go ahead and I'm going to do the second example. I'm not going to write it all out like this. I'm going to kind of just break it down into something that's a little bit easier for us to follow. So what is that? G composite G? Okay, let's do that one. So part B is G composite G, and G of x, if you recall, is equal to x plus 1 over x plus 2. All right, so step 1, let's find a domain for G of x. Now, if you're wondering, well, why am I doing that? Remember, this is the compositional function of G of x. So this is going to equal G of x. So we're going to find right here, where I just, let me draw that arrow a little bit. Actually, let's just use a highlighter. Sorry, when I'm at home by myself, I like to talk out loud a lot. Anyways, we're going to find this domain, G of x. So when we go ahead and we look at this, we know that x plus 2 cannot equal 0. So I just subtract 2 from both sides, and I find that x cannot equal -2. So this is one part of, or this is one exclusion of my domain. Now, part 2, we need to find a compositional function of G of G. All right, so let's go ahead and let's do that. So what I'll do here is I'll actually do this one for us. So we know we're evaluating G of x plus 1 over x plus 2, which means, just give me 1 second, write it out. So I'm going to put x plus 1 over x plus 2 wherever I see the variable x, because I'm just go ahead and I'm going to do this. And now we're going to go ahead and we're going to just simplify this real fast. So in the numerator, we are going to get x plus 1 times x plus 2 all over x plus 2 all divided by x plus 1 plus 2 times x plus 2 all over x plus 2. And all I'm doing is just finding the common denominator and combining. This is going to reduce that into x plus 1 plus x plus 2 all over x plus 1 plus 2x plus 4. All I did there was just divided fractions. In other words, the x plus 2's will reduce, and you can distribute the 2. And then finally, combining like terms in both numerator and denominator, we get 2x plus 3 over 3x plus 5. Okay? So, if you now just remember, for step 1, we found a domain for g of x. That's right here. It's already boxed in. For the compositional part, we know 3x plus 5 cannot equal 0. So we just go ahead and we solve this. Subtract 5 from both sides, and then divide both sides by 3. We find x cannot equal negative 5 over 3. Okay? Finally, my third step is I just draw like the little number line. Here's negative 2. There's negative 5 over 3. I know at negative 2, remember, it's undefined. Negative 5 over 3, that is also undefined. So, the intervals where we have a defined function will be negative infinity all the way up to negative 2. And then in between negative 2 and negative 5 over 3. And then finally, negative 5 over 3, comma, infinity. So, our domain for the compositional function of g and g will be negative infinity to negative 2, or negative 2 to negative 5 over 3, or negative 5 over 3 to infinity. All right? So I hope this kind of clarified how to do that problem. Domains can definitely be tricky. And the way that you want to think about domains is like I said, just like a calculator. You got a really special calculator, and it can do almost anything you want it to do number-wise, but it only does the same function over and over again. The only thing is, you don't want to break the calculator, so you don't want to put a number that will make our denominator 0. So I hope this helped, and I will see you in the next problem.